All right, well, thank you guys. Pleasure to be here. Yeah, David Haynes. My name is David Haynes. I currently am the program lead for the Bird Program for Yellowstone National Park. I've been associated with the program since 2011 in a few different capacities, and came on as a Park Service employee at the end of 2021, and then took the lead of the program around the end of 2022. First thing I like to point out is all these logos I have down here at the bottom. Bird program for the park is a relatively small program, and so I like to point out all our maybe not all, actually probably have more collaborators than this. This is just what came to mind earlier. But we really wouldn't be able to accomplish a lot of what we do without collaboration. We're not exactly a research-based organization, but we do have research questions, and so being able to work with universities and nonprofits means a lot. Not just because we're in the YF building here, but I always want to point out that much of what we do we would not be able to accomplish much of what we do without Yellowstone Forever. They've been a big funder for the Bird Program since I came to Yellowstone in 2011. So with that, kind of jump into some of this. So I always kind of like to kick off just a couple little basic bird facts of Yellowstone. Here in Yellowstone, we have approximately 150 breeding species of bird. Now, 2/3 of these birds do leave in winter, and so we're left with about 50 year-round residents, and anywhere from maybe 8 to 11 species that we get here in the winter alone. So you might see them during migration on both ends, but they'll spend their entire winter here. Things like red poles and rough-legged hawk and a few other examples. And get a quick. Going back to the screen here. This is actually early spring in Hayden Valley. And here's earlier spring in the northern range, so you get an idea of what these birds are dealing with without even looking at an image of winter there. So it gives you a perspective on why we see this major decrease in number of birds. So the bird program itself for Yellowstone is really first and foremost a monitoring program. That's really what we do best. We're here year in, year out. We follow a number of species, a number of groups of birds. We have long-term data on things like bald eagle, osprey, and peregrine falcon. I'll be talking about peregrine falcon today with you guys. Since 2013, Katie Duffy, who's in the room here, has been surveying for small owls across the northern range for us, establishing some baseline information on owl abundance early in the season. I'm going to speak on trumpeter swans today. We have a long data set on trumpeter swan abundance in the park, reaching back almost 100 years. The common loon is a project that we work on. Monitoring for common loons has been going on for years. And in the more recent years, starting around 2012, we collaborated with some nonprofits. The common loon is Wyoming's rarest breeding bird, and over 60% of that population is in Yellowstone. And then we take on songbirds as different guilds essentially. So we're not looking at any specific songbirds per se, but we do monitor songbirds in different community types, and I'll get into that right now. Oops, it's going. Hopefully it's not just running on me. Okay, so why do we look at songbirds? Essentially, half of the breeding songbirds in Yellowstone, or half of the breeding birds in Yellowstone, are songbirds. So approximately 75% or 75 species are nested in songbirds. An important note here is recent analyses have shown that there's been essentially a net loss of about 3.2 billion songbirds across North America since 1970. So really raising some alarms for this species. These species are in fact nature's canary in the coal mine for sure. So with that being said, our oldest breeding songbird data comes from our breeding bird survey. This is a North American survey that occurs from Canada through the U.S. down into Mexico. Here it's managed by the USGS. It's driving routes across roads throughout wherever anybody wants to establish one really. And when we pull out just the songbird data alone here, so that you're collecting any bird you see, but when we just pull out songbird data, we can see an apparent decline since we've started this monitoring effort. Now, teasing out what causes this is difficult, but a couple things we can look at. We know in 1988 there was a major fire, 1/3 of the park burned. This is likely evidence of that kind of recovery period that right there. But other than that, we know that, starting in the mid 90s, wolves were reintroduced, grizzly bears were increasing, cougars were recolonizing. And so, there's that happening. And at the same time, the environment's changing. And so, these kind of multifaceted things to look at are always difficult to tease out what the problems might be there. But nonetheless, the data is telling us that we as well here in Yellowstone have seen a decline in birds. And I will point out that this data is a little old. This figure, I didn't have time to create a new figure, so it's a little old there. But it's leveled off a bit. It's not. If we pushed out to 2024, you'd see it pretty leveled off in there. So other ways we look at songbirds, and in more recent years, we've taken on some other methods. And so we and this doesn't even encompass all we do with songbirds, but just for the breeding birds, we use point count methods. So these are we do repeat surveys at the same places every year, and we look at birds in mature forests. This is driven by increasing wildfire, so we're losing forest types or mature forests at a pretty high rate here in the park. The grassland sagebrush steppe communities are the most imperiled gilded birds in North America and really around the world. These are the areas that we can develop so easy. We can either farm them or we can build cities on top of them. They're easy. So that's really a driver for that loss. And then for willows, that's a very specific Yellowstone question. There was a historic elk abundance prior to carnivore recovery resulted in the suppression of a lot of willow communities in the northern part of Yellowstone. So we've built off of a graduate project that ended prior to 2008, and we've continued to monitor in those areas. We do banding in an area, and this data best contributes to a larger data set run by the Institute for Bird Populations called Monitoring Avian Productivity and Survivorship. But it does give us a little finer picture of things like productivity and annual survival rates for some of these individuals. I'm not going to be speaking on banding today. I'm gonna kind of pick out. I'm going to talk to you about willows and mature forest for a moment here. So as I said, these willow communities severely impacted by this overabundant elk population. When we look at willows, we're kind of monitoring them in three categories of growth types. We got these suppressed areas that are still suppressed to this day, kind of patchy, still potentially browsed to a bit because of how low they are still growing. And so short, patchy, and heavily browsed. We have release sites, which are sites that are now recovering from being overbrowsed. Some of them are starting to resemble very mature, similar to this category, tall, never overbrowsed. And so this picture on the left, or your right, is an example of a never browsed, a tall there. This is Willow Park, just past Swan Lake a little ways into the park. Really impressive willow community. So, whoa, what happened there? Oh, here we go. That's jumping around. So to give you a little idea of suppressed, so this is actually kind of an interesting little image here. So you have this figure A or picture A up there in 2002 and picture B here in 2015. This is our Black-tailed Deer Creek site. This is also where we ban songbirds. So you can see that's a good example, even though this is considered a release site, you can see a good example of what suppressed might look like. And as I said, we still have some sites that are still kind of fitting into the category. May not exactly resemble that, but still sparsely distributed willows, never recover. But yeah, I mean, even a picture of today would even be more growing up than this lower picture here. Like touching something. So when we look at like just the average data or averages of songbird abundance in these different willow types, you can see that there's it's a little messy because that's what data looks like. There's a lot of variation from year to year. You have different people observing, and so you get this general variation. But you can see in red and gray here that on average, you have higher abundance in these willow communities. And when it comes to richness or species diversity in these areas, it's a clear pattern that these released and tall sites have a higher diversity of species within those areas. When we look a little more specifically at individual birds, like with using the yellow warbler here as an example, you can see that these birds, again, are clearly selecting primarily for tall and release sites. And they are using these suppressed sites, but at a lower abundance. So the Wilson's warbler is a good example of a specialist here, and you can see that in this data as well. And so, despite a little bit of overlap here, it's clear that they're selecting for these tall and almost not selecting for the suppressed or the released at all. We're starting to see, even though you see a drop there, we are starting to occasionally pick up Wilson's warblers in some of the released sites, which is great because it tells us that these willows are still recovering and still kind of hitting that habitat that those birds are looking for. The willow flycatcher, considered a bit of a willow specialist, but and you can see in these early years it really shows that we see a higher abundance in the release sites, but somewhat equal when you average it out across these tall sites. Now we have been seeing them increase in these suppressed sites, and that it's either that these birds are somewhat adapting to this environment, but it's probably more of an indication that some of these release sites are actually starting to recover themselves a little bit, and these willow flycatchers potentially are a good indicator of that. And then we got the Lincoln sparrow. Just one last bird here for you. The Lincoln sparrow is much more of a generalist. They seek out more of these wet environments, but they're not. There's no clear definition of where they're going to find it. You're finding them in all of these environments or all these growth types, and they're not selecting specifically for anything there. So jumping into old growth communities. So we broke again, like the willows, we broke old growth communities into kind of three different categories as well. We have the predominant forest type in the park, which is lodgepole pine, spread widely throughout the park. It's a bit of a monoculture in a lot of the park. And then you got these spruce fir, Douglas fir, pine mixed forest, as well as these basically both these are fairly similar types but a little different. And they're just more of that mix, more variety of tree type in there. And the main point here is that these forest types here are burning at a disproportionately higher rate than the lodgepole pine forest because they're just rare forest types in the park altogether. And so, given that we're losing these forest types, in 2017, Doug Smith, who was the previous lead of the program, wanted to at least establish a baseline of songbird communities in these old growth forest types. And so we established a small number of point counts through these areas and to try to do that. And so this figure's kind of crazy. I didn't have time to create I want to do something different. But anyways, the main thing we want to focus on are the dots here, which are the average abundance. And so you can see clearly that in all years since monitoring's begun, that abundance is always higher in these mixed forests versus just lodgepole pine. More interesting, I think, is species richness or diversity. You can see this is more clear, and so this is different. This is your median here is that black line. So richness, half of it. I'm not going to get into details of that, but you can clearly see that diversity is much higher in these spruce fir forests. So I'm actually working with an individual from USGS to leverage some money to try to do a more in-depth analysis of bird community types within different forest types by leveraging some of this data, some of our BBS data, eBird data, as well as some another survey data type that called IMBCR that's happening in the park, led by the Bird Conservancy of the Rockies. But point being, this is that base level information that we didn't have prior to 2017, and so we're continuing to build this data set. Our crews this year got out and did all these surveys, and so we're happy to continue with this songbird work. So, leave songbirds behind, and I'm going to kind of just quickly jump to other things here. We're going to talk about the trumpeter swan here, deemed in some ways Yellowstone's iconic bird, and that's really due to the long history of swans, and I'm going to provide some of that for you. So, the trumpeter swan was considered once incredibly abundant across North America. However, near the end of the 20th century, or the early 20th century, the species was reaching near extinction. So harvested for meat, feathers for riding quills, skins for actually powder puffs, and wetland habitat in general for a long time was considered kind of useless habitat. So general loss of habitat for the species was happening all at the same time. So by 1933, there were 70 known trumpeter swans left that anybody knew about in North America. They were all right here in the Greater Yellowstone ecosystem. So that's, if you didn't know that bit of history, that's always kind of an interesting thing to know about, is that was the case. Now, when we focus in on Yellowstone, the species was documented during the Washburn-Langford Doan expedition in 1870. But in the 1880s, the species was considered abundant around Yellowstone Lake. However, shortly after that, by the 1890s, reports just generally declined. And now, was it declining because of declining numbers, which was happening, or is it just the fact that people just weren't reporting? I'm not sure, but the point is that we were getting much less reports on them at that time. And obviously, the park was very new at that time. So in 1933, in Yellowstone, there was 27 adult swans left in the park. Now, George Melendez Wright is Yellowstone's first wildlife biologist, or not Yellowstone's, he's the National Park Service's first biologist. So given this knowledge of the declining population, he came to Yellowstone to conduct an observational study on swans. At the conclusion of his study, he and the superintendent at the time and others deemed the Greater Yellowstone as to be the center of recovery for the species. And that's when in 1935, they formed Red Rock Lakes, which is to the west of Yellowstone here. And its sole purpose at that time was for the recovery of trumpeter swans. Management there has changed in the modern day, but that was the whole point of establishing Red Rock Lakes National Wildlife Refuge. So by the late 60s, across North America, there were nearly 4,000 swans known at this time. This was due to other efforts in other parts of the U.S. to reestablish, as well as a discovery of unknown swans up in Canada and Alaska that were previously unknown. Here in the GYE, the numbers had risen to approximately 600 birds at that time. So when it comes for Yellowstone itself, this period between the 1930s all the way through the 1950s, we refer to as kind of this heyday of swans. You can see that those low numbers as of 1931 and this steady increase. I mean, obviously you always have that variation in observational data, but if you draw a line to that, it's increasing. And so, it's fluctuating between 30 to 70 individuals in that period of time. And at 1961, 70 plus adult swans in the park. Now, unfortunately, as we, wasn't unclear at that time, but you can see quickly from this figure here that if we follow that green line there, that 1961 was the start of approximately a 50-year decline in the species. And by 2009 and 2010, there was about 4 birds left in the park, none of which were breeding successfully. And so we really were faced with the question of, do we need to take action here? Is there management needed for this, or do we let birds just run their course? So Doug Smith, again, I'll mention his name probably a few times here. He organized in 2011. He organized a workshop, bringing in regional experts. I mean, given the long history of trumpeter swan work in this area, we're rich with experts in this region. And so he pulled all these people together to help guide some of the questions regarding management, but also to kind of search for causes of decline and brainstorm an idea like that. And so at this workshop, things like habitat degradation, decreased immigration from red rocks was put out there. The recovery of predators was suggested, human disturbance, and also things like genetic depression. Now, nobody can come to any consensus. The one thing that did stand out was human disturbance was recognized as something that everybody could agree is playing probably a factor in this. We do have records of human disturbance causing nest failures in some occasions. So for that reason, because humans potentially played a factor in this, we decided to take action. And so the immediate goal was to increase the number of adult swans, territorial pairs in the park. And so the idea is to start to increase birds while you still have some birds on the landscape. You let those last 4 birds disappear, and potentially it gets harder and harder for birds to recognize that they should be here, and that there might be still a place for them on this landscape. So what does management look like for us? So the first thing we did right away in 2011, after that workshop, we put in this specific nesting platform at Grebe Lake. And so these platforms move birds away from the shore. So, people walking the shorelines or predators moving across the shorelines. It removes them from that. It adjusts with floating water, changing water levels. So this site in particular, in some years, the nest sites would flood out historically. And so that would be one reason for failure as well. And so we deployed that in 2011, and in 2012, the birds used it and produced the first signals at Grebe Lake since 1952, which was pretty exciting to see at that time. And at first we were told that they weren't going to use the platform immediately, and they immediately did. So that was great. So in around 2016, swans showed up at Swan Lake, which is just up the hill from us here. And so we again installed a floating nest platform there, and it took a few years, but by 2019, they produced cygnets for the first time since 1966. So, as we said, we wanted to establish territorial pairs. Ideally, breeding territorial pairs is the goal. And so just by having these two things were immediate, what felt like pretty early successes for us. Now, to address human disturbance, we've implemented some closures. This is always controversial to close something, but some birds are less sensitive than others. This Riddle Lake pair is a great example of high sensitivity. This is a bear management area till July 15th, and so when people come in there, they have young swans, and they move when people show up. They move out to the open water. Things like bald eagles then move in and swipe up the young, and so that closure is in place until the young reach a specific size and age. And right now it's open because they nested this year, but unfortunately have already failed. And then finally, we've been releasing cygnets since 2000, young swans since 2013. This is in cooperation with the Wyoming Wetland Society, and so we take approximately 100-day-old cygnets and release them every fall. And we primarily do that in the Hayden Valley. It's along the Yellowstone River. It's a known congregation spot for birds that after they leave their breeding areas, and also just for some of the floating swans that are around the park. And so the hope always is that these released birds that don't have a mentor can join up with birds that serve as mentors, and we've seen that happen over and over again, which is great. When we look at this, you can see that as of last year, I had about 25 white birds on our fall count. This is the continuation of data that started in 1931, initially as a ground count, but nowadays it's a flight we do every year. We had six wild-born cygnets on our survey, and then we of course observed the release cygnets, the 8 release cygnets we did last September. So overall, it's a positive to see these numbers going up here. When we look at the future of what to do here, this potentially multifaceted cause for decline is obviously difficult for us to deal with. It's hard to say if our management will then be negatively impacted by whatever caused us in the first place, or if we cross that hurdle and we're on our way to recovery. We are seeing these positive results from our management actions. This year we have 5 breeding pairs. 2 years ago we had 5 breeding pairs. A number of these pairs have failed already this year, but just to even see these birds attempting is a big plus for us, because these are long-lived species. They don't need to be successful every year. We do see additional pairs that are paired up and consistently in the same areas, which tells us that these might become breeding territories one day. And some of these released birds have been recruited into the population. In fact, the Grebe Lake birds currently are birds that were released in 2000. Well, at least one of them was released in 2013. So knowing that some of these released birds aren't just going out there and dying, or going out there and flying to a different place is a positive sign for that part of our effort. And we're hovering somewhere around 26, maybe 30 birds, wild white birds in the population right now. The one thing that we're missing, we've had a couple of research projects trying to explore that decline, but the one thing we're missing, I think, is a habitat study, really trying to assess how the resources are today as compared to some of the areas outside of the park where swans might be doing a little bit better. That's a missing component that I hope to take on one of these days. So we're done with swans. We're going to move into peregrine falcons. The peregrine falcon. This is the most far-reaching terrestrial vertebrate on the planet. They occupy every continent except for Antarctica. I think a lot of people know the peregrine falcon. Maybe some don't, but known as the fastest animal on Earth, reaching speeds of over 200 miles per hour in a dive. They're known to nest on cliffs. They don't build nests. They lay right on ledges, but they're also well known to nest on things like buildings and bridges, kind of artificial cliffs, as you might think about it. They prey primarily on birds. They primarily capture birds in flight, and so that's kind of what the basis of that primary bird diet there. And then they really serve as kind of the poster child for the severe impacts of DDT around the world. And so when we talk about DDT, this was like the best of its kind pesticide at around 1946, 1947, released into the world, and used extensively, as I said, worldwide. Now, its primary metabolite, DDE, was accumulating in a lot of different species, but since we're talking about peregrines, these top predators are accumulating more of this than, say, individual songbirds that might be eating a few sick insects from the pesticide. So that accumulation of DDE resulted in extreme thinning of eggshells, and that resulted in high failure rates of nesting peregrines. When we look at North America, the declines were first detected in the eastern part of the U.S. This is where peregrines overlap with a lot of people. People knew about peregrines in some of these places, and so they were able to see this happening early on. Now, the species was listed as endangered in 1970 under the Endangered Species Conservation Act of 1969, later placed under the Endangered Species Act. But in 1982, restrictions were placed on DDT, and with those restrictions, the release of over 5,000 captive-raised peregrines in North America, as well as natural reproduction that started to occur once we removed this from the DDT from the environment. The species were removed from the endangered species list in 1999. So here in the Rocky Mountains, peregrines obviously occupy this large, vast landscape, and because of like the difficulty of moving through an environment like this, the records were generally limited for what historical numbers of peregrines might look like in the Rocky Mountains. Now, James Anderson in 1964 out of Colorado led the first survey, and this survey extended all the way up into Canada. They only found 13 of 47 territories occupied, showing that the effects of DDT had fully infiltrated the Rocky Mountain population. A very similar survey led by Anderson in 73 from New Mexico to Montana showed very similar results. So when we jump down into Yellowstone, we're kind of finally getting there with Yellowstone. First recorded record of peregrines in Yellowstone was by Milton Skinner. This was Yellowstone's very first naturalist. Wrote some pretty great information on birds, early baseline information on birds. So he had that first record in 1914. By the 1960s, there were only about 68 known territories, likely much more numerous than we could ever document, obviously. But by 1970, the last known territory had gone vacant, and at that time, the species was considered extirpated from the region. So within the GYE in just this whole region, there was nobody believed that there was any peregrines left. Interestingly enough, Yellowstone itself became the center of recovery for recovery efforts for peregrine falcons for Wyoming, Idaho, and Montana, and that included the release of 36 peregrines from 4 release sites in Yellowstone. It also involved an additional 644 peregrines released from a 260 kilometer radius, or what, I'm not exactly sure how that number washes out, but between 1980 and 1987, 644 more birds were released within the region. And then in 1984, Bob Oakleaf and Jerry Craig noted the first reoccupation in Yellowstone. And this was by a banded pair. They identified the bands. These bands that on all these release birds were breedable bands. They had U.S. Fish and Wildlife Service bands, but they also at the time U.S. Fish and Wildlife Service bands, and then they also had breedable bands. And so they knew that these birds came from 80 and 100 kilometers away from their release sites. The interesting thing about this reoccupation in 1984 was that site that they first reoccupied was that last site that went vacant in 1970, and really I think shows that innate recognition of what is ideal nesting habitat for the species. So that was one cool little thing found with that. So in 2015, we published a paper on some of this data, on some of the data we had regarding peregrines. The objectives were to determine the trends in occupancy and reproduction, describe nesting diets and what they're feeding their young, and also compare eggshell thickness to earliest published records. So to monitor peregrines, it's a tough job. It takes you some beautiful places, but it truly is not the easiest. This is a bird of the size of a crow that occupies massive cliff faces and flies at super high speeds. And so it can be difficult, but the goal is to get to these sites. Do we see an occupied pair at these sites? If there's two occupied pair, male female, then we determine are they breeding, and if they're breeding, what's the outcome? Are they successful? Do they fledge their young, or do they fail in the process of doing that? In order to collect data on prey and eggshells, we repel down into nests once the young had fledged, gathered up all the feathers and bones and so forth, as well as collecting all the fragments of eggshells. And for prey remains, we sent all that to an individual by the name of John Schmidt, who's the best of this more than anybody else. And he identified and quantified all the prey remains. And then we sent all the eggshell fragments to the Western Foundation for Vertebrate Zoology to do the measurements of thickness. I feel like I missed. Oh no, okay. So when we look at occupied territories, as you can see here in this figure, the territories, we steadily saw an increase from really starting in 1988. So that pair in 1984, we had a single pair from 1984 to about 1988. Starting in 1988, the population really started to take off, and by 2007, we had 32 pairs. So, equaling about an average of about 2 new pairs a year as we got to that point. So this figure here is pointing out for years and number of territories monitored. And you can see that prior to 2007, up to 2007, we were monitoring all territories as we found them. And so we're essentially censusing what we knew of peregrines in the park. Now that vertical red line is a change in management. That's when Doug Smith took over the bird program. At that point, the program was diversifying a bit, and so we really didn't have the ability to follow all peregrines. And so we essentially started sampling the territories. And so for that reason, when we look at things like trends in occupancy, I like to divide it up in these two phases, because if I combine them, it doesn't really work very well because the methods had changed a little bit. So when we look at that, so we look at this first, 98%, we had a mean in those first years, a mean of 98%. I mean, all territories were essentially occupied in all years. And this is indicative of a reestablishing population. Resources are abundant. There's lots of space for birds to breed. And so we're gonna see something like this ideally. And so when we jump into the next phase, we see a lot more variability and a lower mean. So we're about 83% in the years, these recent years, and overall we still see we're generally seeing a positive trend here, but no statistical evidence to say that it's actually occupancy is increasing or anything. But it's just but we do see a positive slope there. But overall what we think we may have maybe not missed, but what's likely we're seeing here with the decrease in occupancy at sites is that at this time the population likely hit carrying capacity or even exceeded carrying capacity. So basically the ability of the environment, the available resources to support a sizable population. So it's more likely that some of these territories that this variability we see nowadays is due to the fact that some of these territories have gone vacant. And a lot of these territories that have gone vacant, I will say, are at first glance are territories that I would consider lower quality nesting habitat for these birds. So, looking at reproduction, there's kind of three main parameters we look at when it comes to when we average out reproduction. One being productivity, which is the number of young fledged per occupied territory. And again, we see a negative slope, but we don't have any strong statistical evidence to say that there's a decline. But this is why we keep monitoring. But what we see here is we see an average of about 1.5 birds produced per occupied territory. So for all the pairs out there, they're producing about 1.5 birds per occupied territory. Jeez, I think I'm hitting this. Sorry, guys. For nest success, percent of occupied territories that fledge at least one young, we're averaging around 71%. And again, a negative slope, but statistically insignificant. And so high variability for both of these, obviously, but hanging at a decent range there. And then finally, brood size. So this is the number of young fledged per successful territory. And right there, we're at around a little over 2 birds per successful pair. And again, we're seeing this negative slope. Good reason to keep monitoring these birds, but still not currently a reason for concern. So nesting diet. So in 2010, 11, 13, and 14, we collected prey remains and eggshell fragments from a number of areas. I can't remember exactly how many right now. But we identified 186 individual prey items representing 40 species. Now, not surprising, 97% of these were birds. 63% were terrestrial species, 22% shorebird, and another 12% were water birds. One interesting part of this was that 10 of the species, and so this is the breeding season, this is the summertime, and 10 of these species were birds that we consider non-breeders here in the park. And so they're birds that we rarely even see this time of year, yet peregrines we're finding them. Franklin's gull is a good example. It is a big white bird. It's meaty. It's probably pretty ideal. We actually, one bird we've never actually observed, nobody's actually observed in the park, was a red phalarope that was found in one of the nests. So they are finding those rare birds better than we are, I'll tell you that. And then a couple notable prey items was 4 individual fish, likely stolen from neighboring nesting osprey, I'm guessing. And then 1 American martin was found. You photograph of the leg right there in the nest. And again, I suspect that was maybe stolen from a neighboring red-tailed hawk or Swainson's hawk in the area, I'm guessing. Hard to say, but interesting enough to find those there, and definitely goes outside what we think of when it comes to peregrine falcons. So we're looking at eggshell thickness. So here's our baseline here. No thinning. So we have percent thinning on the x-axis here, different periods of time on the y-axis, and this vertical dotted line here is that threshold. When thinning exceeds that is where you have reproduction's affected by the thinning of the eggshells. And so we have our baseline. Central Rockies were measured. This is a very large sample actually, which is nice, and includes areas not in Yellowstone but not far. And you can see that thinning was well above that threshold. By the late 70s, we're still above that threshold. Reproduction still affected. This was more Southern Rockies. That's the nearest we could find for that time period. Now, we were fortunate that there was a study in the late 80s here in Yellowstone, or not in the GYE, but included Yellowstone, where they sampled eggshell thickness. And so we were able to see that around that time, thinning had reached below that threshold. We know reproduction was doing much better at that time, but thinning was still at around 12-ish% at that time. And this phase, which actually does include 2014 as well, but I couldn't fix that on the figure right now. So you can see that we're around 4% at that point. So this decline reflects what we were seeing in the local population as well as the world population. So so that's kind of where we landed with percent thinning there. Now threats persist. DDT still, not that long ago, DDT was still found in fish around Yellowstone Lake. There was lots of DDT spread. In fact, over 60 tons of it spread in the 50s for spruce budworm in the park. So that still persists in the environment. Obviously, doesn't seem to be having a problem. There's other contaminants like PCBs and flame retardants, some of which have been outlawed, but are still being used because the products are still being used out there. They're not actively putting these retardants in things anymore, but they're still out there, and things like that are showing up in the tissues of these birds. And recently, in the east particularly, they've been seeing some pretty dramatic declines of peregrines. They're seeing really high turnover rates of individuals, lots of subadults trying to breed with adults, which is indicative of a failing adult floating population, a population of non-breeding adults that are waiting to occupy territories. And so avian flu is thought to be one of the factors here. They're the perfect candidate to contract it. They're eating birds. They're on a regular basis. So it's concerning, and we're trying. I'm trying my best at this point to tease out, not to tease out, but to not kind of miss something like this happening here. And we do occasionally see subadults breeding. In fact, right now we have some subadults occupying territories. But we've always seen that, prior to this outbreak of avian flu. So at this point, it's something to keep an eye on, but we'll see. But just again, coming back to that value in this continued monitoring, is you just never know, and you're going to miss it if you're not watching. So at this point, we're in our 42nd year of monitoring across these two different efforts. We've identified 42 total territories. There are more territories than that in the park, and not all these territories are obviously occupied anymore. And occasionally we see peregrines in other spots, and we suspect those are territories, but it's a big park, and we have a lot on our plate. So we as I showed you, we have no obvious trends in reproduction and changes in reproduction since monitoring picked back up in the 80s. And all those values on productivity, success, and brood size are all at or above the target values for U.S. Fish and Wildlife Service set years ago. And so that's a positive note. Now that 83% occupancy in the second phase is just under the threshold, or where U.S. Fish and Wildlife set it. So something to look at, but maybe not to be concerned just yet. And overall, based on this, we tend to think this population is likely stable. Okay. Where am I at? Okay, we're gonna get into golden eagles. Let's keep going here. I'm kind of gonna end with golden eagles here for you guys. This is a species one of the species that kind of brought me to Yellowstone. So the golden eagle here in North America is recognized as a species of conservation concern. And this is really due to uncertain population trends and some rough, only recently derived estimates of overall abundance. But more than these uncertain population trends, it's these growing list of anthropogenic threats that we know are acting on the survival of the species. Some recent demographic analyses that showed that 63% of all known mortalities for golden eagles are human caused. Another study showed that any additive human-caused mortality is likely to cause declines or exacerbate declines that may be ongoing already. And then a study that came out only a couple of years ago that made national news was that 50% of all bald and golden eagles here in North America are experiencing chronic lead exposure. So that's repeated exposure to lead. And so, with every exposure, it's impacting their ability to probably successfully breed. At times, it's killing the birds, obviously. And so, obviously a prolific problem here. When we jump into Yellowstone National Park, since monitoring began in 2011, we've identified a minimum of 30 territories park-wide. Now, there are definitely more than 30 territories in the park. And I know of some spots I just haven't had time to go out there and document them. But nonetheless, the main thing I want to bring home here is that of these 30 territories, 22 are located in the northern range, which I now have highlighted there on the map. So that equates to a density of around 45 square kilometers per occupied territory. And when you look at this range within North America, anywhere from 18.5 square kilometers, which is coastal California, year-round ground squirrels, lots of great, year-round positive conditions, up to 252 square kilometers. You can see that we're kind of at that higher end of that spectrum for density. And that number reflects a lot of what we see in other areas within this region for golden eagles. Now, since we've been monitoring, all territories have been occupied in all years, which is a positive note. However, nest success, which I said earlier was the percent of territories that fledged at least one young, and productivity, which is the total number of young fledged populated territory, has been highly variable. Last year was our best year we've ever seen, but nonetheless, when you look at our averages, we're at about 28% for nest success, about 0.35 for productivity, pulled up a bit from last year's data. And to give you some perspective on that, I told you what the peregrines were. Peregrines were, what was it? Success was around 70 something percent. The productivity was 1.5. So we're at productivity of 0.35. Different species, but to kind of give you a comparison for the species, we're actually fortunate to have two golden eagle studies to the east, one to the east and one to the north of us. So one near Cody, one near Livingston there. And you can see that productivity in these areas is more than double what we see here in Yellowstone. So just to give you some perspective there, golden eagles are always producing generally at a lower, on average, lower than one, because that's just part of their natural history. There are in some places years where they'll cross that one line, but so it's always low, but very low is what we've seen here. So that really leads to a question of like, why are we seeing this high density coupled with these low reproductive rates in the northern range of Yellowstone? And unfortunately, this is a question that we're left to speculate on more than we can answer. And so we do have hypotheses related to this, and for that reason, I'm going to share with you a little bit of this. But it's speculation still at this point. So one of them revolves around carrion. This is an important research for eagles, no doubt about it. The importance does vary across the species range. Like I said, birds living in coastal California don't need to worry about carrion because they're feeding on ground squirrels day in, day out. But here in Yellowstone, based on data we've been collecting for a number of years, collecting prey remains out of nests, looking at nestling diet, and more recently placing cameras in nests to capture the prey items and get a more definitive number of prey and species that come to the nest. We know that most of the prey that they're feeding their young in the summertime is generally unavailable in winter, whether it be hibernating or species that have migrated out of the region. And so for that reason, we kind of think about this going back to this historic elk abundance that I spoke about with some of the songbirds. Prior to carnivore recovery, again, cougar increase or cougar recolonization, the reintroduction of wolves, increasing grizzly bears. The northern Yellowstone elk herd numbered upwards of 20,000 individuals, and this is considered a very overabundant population. And this overabundance would typically result in high levels of winter die-off, really kind of in that late winter period when these birds are initiating their breeding. So presumably providing a really reliable food source for the golden eagles at a much needed time. Now post-recovery, the population has declined. Again, we have an older figure here, but the population of northern Yellowstone elk herd, I think has been floating around 5,000 to 6,000 individuals pretty much since that time. And these are just minimum counts. These are not estimates of elk population. These are just flights that they do and get these big number counts. So basically, what we hypothesize is that the density of eagles in northern Yellowstone may be a relic of this elk abundance and these high winter die-off events, and that reproduction is a response to that decrease in carrion availability at that time of year. But again, that's something that we have not been able to tease out because prior to 2011, there was no information on golden eagles, so we don't know if the population increased during this time here or even starting further back here. It's unknown. So what we can do is we can try to research what's happening now, what we can take into consideration, what we see here, and what these birds are experiencing in the current day. And so some of our research we've completed to some extent, and some other ongoing research I'll talk about in a moment, was to look at what components of golden eagle habitat influence the reproductive success of eagles in the park. And so for that, we take into consideration what factors drive reproductive success. And for raptors, it really comes down to food availability and the weather they experience in a given year or in a given season. I also want to point out that they're known not to breed every year. It's believed that females that can't meet these conditional requirements for breeding will just forego breeding in that given year. And also, life history theory suggests that long-lived species, wild species, maybe not humans, have only a fixed investment in their young in order to maximize their own survival. So you live another day, another year, you have another chance to breed. These birds can live 20 to 30 years, if not more. So when we jump into the data, so earlier I showed you the productivity and success. When we look at the data in a slightly different way, from a probability standpoint, we can think about, all birds start the year as non-breeding birds, and they're either going to choose to breed, lay eggs and breed, and if they breed, they're either going to be successful or they're going to fail. And so when we take the data and look at it from a probability standpoint, we see that any given pair of eagles in a given year has only a 32% probability that they're even going to lay eggs in a given year. Now, if they lay eggs, there's a 59% probability that they'll be successful. So a little bit of an uptick there. The objectives of one of the objectives of some of our research was to look at how the weather these eagles experience and the resources available to them influence this probability that they're going to lay eggs and the probability that they'll be successful if they lay eggs. So you have to kind of figure out what variables you might want to include in these kind of analyses. So we took some weather variables like temperature and precipitation, and we also derived some weather events. So weather is either impacting birds directly or indirectly, and so we're not really truly trying to tease that out here, but the thought more is that these severe weather events might have some more direct effects on these birds, but not always. And so we also took into consideration landscape characteristics, things like topography, aid in things like updraft for these birds, so allow these birds to fly without having to flap their wings, conserve energy. We took into consideration land cover type, so vegetative cover, to serve kind of as a proxy for prey. We don't have things like small mammal prey data in Yellowstone, so considering the availability of grassland and sagebrush steppe communities to these birds, and I want to point out real quick that we consider this at the scale of an eagle's home range. So with some of our telemetry data, which I'm not really getting too much into today, we can estimate home ranges for these birds. And what we did is we took these estimates of home range size during different seasons, and we averaged those out and placed those around territory centers to extract some of these variables. And we also included proximity to the nearest neighboring territories. This was to address a prediction that birds nesting in closer proximity to each other are occupying areas of higher quality habitat. And to address the carrion question, we use estimates of wolf kill biomass. So this is the biomass acquired per wolf per day during the winter and data coming from out of the Yellowstone Wolf Project. And so use some of this data to look at how that might be affecting these probabilities. So when we look at these factors influencing the probability these birds are going to lay eggs or initiate breeding, really didn't come up with much here. What we did see is that during the winter months of the year, the number of occasions where you had precipitation on consecutive days. Now this didn't mean that it snowed all day every day for 3 days. It's just all we were detecting is, did it snow 3 or more consecutive days? And so the more occasions that they experience weather like this, the probability of laying eggs decrease. And this, snow is going to potentially cover up carrion. It's going to potentially limit how well they can actively see or even fly out in the environment. So with every additional occasion of this, they're using energy and potentially not acquiring energy. So that's where I kind of stand with that one. When we look at factors that are affecting the probability of them successfully fledging young, we again find some weather variables stand out here. But now we're looking at this. We're moved out of that core winter time, and now we're into this early, what we call late winter, early spring, and we see in years where snow persists on the ground longer into the breeding season, the probability that they're going to be successful decreases. And so things like snow on the ground is potentially going to delay the emergence of the mammals that they're switching over to. Carrion's decreasing. They want to switch over to these live prey bases. It also potentially just provides cover for some of these small mammals to move underneath the snow. We found a negative effect of severe weather. This incorporated both low temperatures and high precipitation. So with every increasing severe weather event during this same period of time, the probability of success went down as well. So at this time of year, you have a male that's essentially providing food for the female and potentially the really young nestlings. And so weather events like this are directly and indirectly potentially preventing these birds from successfully providing enough food for the family, essentially. And a female that is unable to maintain enough reserves is not going to be able to maintain incubation. We did find some positive effects. So we did find home ranges that were more rugged in Yellowstone showed a higher probability of success. And so, again, as I said, these areas are providing updrafts. They're also providing high areas for these birds to perch and scan for prey, conserving energy that way, as well as conserving energy while they're actively flying and hunting for their prey. And we did find a positive effect of nearest neighbor distance. So birds nesting in closer proximity to each other were more likely to, or had a higher probability of successfully fledging their young. So this did support prediction that density is potentially driven by an aggregation of higher quality resources that then results in higher success. Now, for wolf kill biomass, as much as I would have liked to pull something out of this, we found no effect here. And I do think that this is the primary source. Wolf and cougar are really the primary sources of carrion in the modern day of Yellowstone. And I tend to think that there's something there, but until we get there, we'll see what happens. But I want to point out that this variable, unlike those other variables that I took at the scale of their home range, this was an annual average that I blanketed for each year of stuff. So it doesn't take into consideration the spatial variation. I didn't isolate birds that maybe had a higher potential to get more carrion than others, which that would probably help. But this particular variable doesn't have that included, and it also doesn't take into consideration the availability of how much meat was left there. Wolves have the ability to consume their entire kill, so possibly not the best metric, but it was the best I had at the time when we conducted this analysis. So at this point, I will say that what we've seen so far has advanced our understanding of why we're seeing these low reproductive rates. We see how harsh weather is negatively influencing reproduction, as well as these positive influences of habitat resources on reproduction. As we look forward, we're currently working on things like adult survival, which is a really key component to the population stability. Long-lived species don't need to breed much, and maybe Yellowstone is a place where their survival is higher than what we see as a national average, and reproduction doesn't need to be very high. And then things like environmental contaminants. So this bird on the right there, it was the very first bird we had put a transmitter on. It spent the big game hunting season up in Gardner and up to the Paradise Valley, came back within its home range, and died in December after we had applied the transmitter in the summer of 2018. Sent it in for necropsy, came back with lethal levels of lead in its liver, definitive death by lead. And so, recognizing that these boundaries that we draw around the park have little influence on especially in the context of birds, little influence there. And so we do recognize that there's threats out there. That currently is the only bird. I do have a bird currently in a freezer that is still needs to be sent in for necropsy. There's suspect that likely been a culprit there, and we need to further examine diet. We continue to put cameras out at nests to better understand nesting diet. We're also interested in doing some DNA swabbing on the beaks pretty soon here, starting in the winter when we're doing winter capture. to get a better idea of winter diet. It's a new method that had really only recently been published on in the last couple of years, and I've just been trying to find time to start to employ it, but it's difficult to fit everything in. And then, coming back to that carnivore contributed carrion, we're fortunate to have multiple concurrent studies happening in Yellowstone. We're tracking eagles. The Wolf Project is tracking wolves. They're tracking cougars. They know of known kill sites. So I'd like to really more specifically analyze this from an individual level and really look at on how the birds are selecting for these the availability of carnivore contributed carrion on the landscape. And there's a lot of other research questions that I'm not going to get into there. So that being said, if that clock's right, I ate up a lot of your guys' time. Thank you.